I started doing a little bit of work on this board, which is the IF amplifiers, the audio and video detectors, and audio and video output amplifiers, but I quickly realized I didn't have a lot of the parts I needed. Resistors, yes, and I replaced a few that were out of spec, but capacitors, not so much. In particular, either they are much lower in voltage and higher capacitance than what I normally stock for tube equipment, and also a lot of them are non-polarized. Electrolytics, but they don't have a positive and a negative. You can hook them up either way. So I had to place an order, and my parts have just arrived from Mauser Electronics. Now, non-polarized electrolytics are not used that commonly, so the options were fewer, although I was able to find what I needed. However, I was curious to see what advances of technology might have brought in terms of other options. So some of them are conventional non-polarized caps, and some of these are polarized, like these Nichikan 220 microfarad 25 volts conventional electrolytics, but a bunch of them, find some. I know there's some non-polarized in here. Yeah, like these. There's also something else I realized is that non-polarized is not necessarily the way you're going to find these. They also call them bipolar, so these say BP on them, bipolar. And notice there is no indication of a positive or a negative on them. So here's 47 microfarad, it's 16 volt, standard little electrolytic capacitor package. So it's certainly smaller than the originals, which are these large black cylinders on here. But there is another option, and that is these guys, these little itty bitty little blue capacitors. What these are multi-layer ceramic capacitors. These little itty bitty capacitors are actually 6.8 microfarad, 10 volts. See if I can find the ones that are equivalent to this 47 mics. They're 47 microfarad. That small. They use X5R ceramic dielectric, which is not as good as NP0 or C0G, which is an excellent temperature coefficient, virtually no change in capacitance over a very large temperature range. But X5R is not bad. Over your typical temperatures are likely to see like 0 to 40 degrees Celsius, almost no capacitance change. So I figured I'd get both. I'm going to try using the ceramic first, and if there's any issue with them, because there's another property ceramics have is that they can vary in capacitance with the applied voltage. So if there's any issues, I have some of the conventional ones I can go to as a backup. But I'm looking for the largest ones, somewhere in here. Wow, those suckers are really small. 4.7 microfarads. Look how small those things are. Barely anything to them, just a little lump. 2 wires coming out. And somewhere near I have 330 microfarad ceramics. Well, let's see what else I got. So I got conventional electrolytics, because some of these are polarized, and I'll just use those. I got the ceramic, bipolar, or non. No ceramic cap is going to be polarized, so just by definition they are unpolarized. Got a few half-watt 1% resistors that I didn't have on hand, just to kind of replenish my stocks. I encountered something else I hadn't expected with resistors. So these standard metal film half-watt resistors, conventional size. Well, they've also been making strides in resistor technology. These are also half-watt metal film resistors. Look how friggin' small those things are. They'll work fine, but I just don't want to use components that are this small. Hard to read the The color codes on them, how small they are compared to these other guys. So, you know, when I order these, they include a little stock photo you can look at, and these look like the same thing, but now that I can see them in person, oh well, that cost a few cents, so not a big deal. Also got some plastic film capacitors, some oddball values I didn't have on hand. Not so easy to find, but you can still get axial capacitors. These are for the main DC supply. 2,200 microfarad, I think it's 16 volts. Those will replace the giant GE caps I found inside. In other words, like that gold one down in there. Big guy down in there. I was mistaken, actually 47 microfarad is the largest non-polarized cap I needed. So, 47 microfarad electrolytic, 47 microfarad ceramic. And you can get ceramics, I think, up to 470 microfarad, but very low voltage, only like 3.3 volts. So, neat stuff. And I believe this lead spacing matches the old ones. These I would have to spread out a little. Alright, now that I've got everything on hand, I can sort through them and start recapping in earnest. Something else I wanted to mention is I've talked many times about replacing selenium rectifiers in these old sets, or using diodes for filament droppers, and I'm always using 1N4007s, which are rated 4,000 volts, 1 amp steady state current. Well, I should have been using these, which are 1N5408, 1,000 volts, 3 amps. Price difference is negligible, and these are far more robust. Also, not such a bad idea to put two in series, especially for filament droppers, so if one fails and does a dead short, you still got one as a backup in series with it. So I'll be using these guys from now on. A little bit bigger, but, as I say, far more robust. It just so happens that 47 microfarad non-polarized cap is going to go right in here in place of this guy, which I'm now sure was a replacement. 50 microfarad at 25 volt non-polarized. Well, I referred to both the SAMs, and I got a copy of the Philco original service manual from the early TV Foundation, and here's C6. It's the same as the others, cylindrical vertical capacitor. 50 microfarad, 10 volt non-polarized. So I don't need the 50 volt rating, or sorry, the 25 volt rating, so I can go with this guy. As far as getting out the old leads, I don't use solder wick or anything. All I do is cut the component out, which I've already done, and cut the leads somewhat close to the board. Heat it up from the other side and just push the couple of leads through. There we go. That's it. And the holes are unplugged already. If I needed to, I'd just kind of poke out the solder, but I don't even need to do that. Oh, the leads are just a little bit too close together, so let's move those, bend them apart just a little bit. side. Solder it up. Using some small diameter multi-core solder. When I'm all done, I think I'll take a little alcohol, Q-tips, and clean up some of this excess flux. Quite a bit in some areas like here. Right. That is that. So you can see when I'm done, place of all these black caps are going to be much smaller new ones. And I'm not really concerned about retaining the original look. Especially when I'm pretty sure these aren't the originals anyways. Let's see about taking one of these out. One of these black guys. I have not tried that yet. It looks like the leads are not even bent over on the other side. They're very vertically. These two right here. So I think I can just heat it up. Bam, out. No damage to the trace. No fuss, no fuss. Alright, so now this is 100 microfarad, 5 volts DC. I'm going to double check all of these against the search C7. Parts list C7. 10 microfarad, 5 volts polarized. I'm just going to dig through all my parts to find it. 330. Go. 100 microfarad, 10 volts, so twice the voltage rating, no problem there. Really hate this tape. Clean off all the residue from the leads. Alright, now I'll have to figure out which side is supposed to be negative. Looks like on these old originals there's 3 pluses near one leg, and that was the positive. Let's see on the diagram, do they indicate the positive side? Oh no, they do not. Should have paid more attention when I took it out. Looks like it's not marked on the board either. Well, now I'm going to have to trace it out, because I can't tell which side is positive. Alright, dig on the schematic. Here it is. And on this schematic, the plus on the left there is the short bar with the plus, and the negative is the symbol kind of wraps around. So the plus goes off to the wiper on the contrast control. As for the non-polarized, they are indicated by that symbol, just sort of like back-to-back electrolytics. Alright, so I need to figure out plus to contrast. So I'm pretty sure that's this one, because it snakes off and goes around through there and over to this contrast control. So that should be positive. Bend over my leads a little bit. Try to make a little thing like that. That way they stay, component stays raised off the board a little. So, like so. So it's a single-sided board. Traces are on the bottom, but on the top they silk screened it with this pattern showing all the traces. So this mimics the actual copper on the underside. So you can kind of trace out the circuitry. Alright, so I will just continue doing the same thing for the rest of these caps.